I actually don't think we have enough time to do this next section. Let's see. Yeah. Okay, I'm gonna speed through it in 5 minutes because I think it will be good to go over ConOps right before our ConOps presentation, even though I've done it in EPIT 301. So, design reference missions and baseline system architectures. A design reference mission establishes an operational context, descriptions of the environment situations in which solution concepts are expected to operate, an operational narrative of expected behavior, including a sequence of operational activities and interactions between systems in an environment, and sample measures for establishing goals for a mission. We don't have a design reference mission. These are usually reserved for very large missions and/or missions in which stakeholders aren't going to be involved in the development or aren't from a technical background. We are skipping directly into defining a concept of operations and designing the system architecture because you all are of a technical background and you as a stakeholder will be a part of the whole process. But if you are in a project that has a design reference mission, they're usually created by the stakeholders very early on, and they can take the form of a narrative, storyboard, pictogram, timeline, or combination thereof. This question of what DRM form is most common and also most effective, I don't think that there's a form that is most common, but most effective, let's see. A DRM is effective if it is planned to a sufficient level of detail to elucidate the content, risks, difficulties, technologies, scale, and sometimes cost of a potential endeavor. They are most often used to guide the technology development efforts. There was a little bit of literature review to count 46 design reference missions in a document used recently to guide NASA technology planning. They're also used to guide early developments along a path to the endeavor, such as determining the size and capability of a new large launch vehicle. For example, the Lunar Surface Reference Mission is a tool, not a prescription for a program. The selection of tasks to be accomplished will vary according to the emphasis placed on the major themes of lunar exploration and development, and the capabilities of specific missions. I only have a couple minutes, so I'm just gonna zip ahead. You can think of the Artemis CubeSat kit not as a design reference mission, but instead as the baseline system architecture. Here's a concept of operations of a student team here called Team Pono of their mission called KAO. KAO is the same size as Artemis when it comes to the CubeSat frame and served as the baseline mission for the Artemis CubeSat kit. So there was a question about, will this class be doing something similar? And absolutely, this is a good case study of how you can use Artemis CubeSat kit. So KAO has 4 different phases that describe how the proposed system will accomplish the mission objectives. I think that this concept of operation is totally fine for a first preliminary pass, but I would like to see more detail, such as, here's a concept of operations for the Artemis 1 mission, where you have the mission statement up here, and then you note the different various mission phases, the level of detail, yet the succinct display of all of this information. So this is what I want you to aim for. Okay, and just really quickly, a space systems architecture is a description of physical hardware, processes, and operations to perform the mission. The space systems architecture can be broken down into main 3 physical parts: the space segment, the launch segment, and the ground segment. One can ask, what kind of these do I need? Do I need the deep space ground station, or can I get by with my DIY ground station? What kind of launch vehicle can I get? What size of spacecraft bus do I need? So this is kind of the larger framework that you should use when thinking about your spacecraft design.